Hi academic stars, welcome back to Caltex Academy. Today we are looking at this examination question, and that is from Earth geometry. So the question says W, X, Y, and Z are 4 points on the surface of the Earth as shown in the diagram below. So these are the points W, X, Y, and Z. They lies on these two latitudes and the two longitudes of 15 degrees west and 105 degrees east. Those are the longitudes, and latitudes of 80 degrees in the northern hemisphere. And we have also 30 degrees in the southern hemisphere as the latitude down here. So what is the question saying? Okay, part A is saying calculate the difference in latitude between W and Y. Y is here, W is up here. So they're talking about latitudes. So the latitudes are this one here from above and the one down here. So the difference, since they're located in two different hemispheres, then we have to add them. We talked about this one severally. You can check on those videos. The links are in our description of the video here. So what we have to do, I have some diagram here for us to work on. Remember, this one is in the southern hemisphere, the one with 30 degrees south, meaning the Earth center is somewhere here. We can call it as O, and the distance is this up to here is difference. Now, maybe we can extend a line like that at the center there, and we call this difference as what? Theta. And from here, for us to get that angle difference theta, we can say we're just simply summing them up, and we're summing 80 degrees. The north or the south, we simply add the two angles together, and if you sum that, what you get is 110 degrees. That is the difference, and the answer is part A of the question. Let's look at also part B of the question, and it says calculate the distance in nautical miles between 1, X, and Z. Between X and Z. Still, this one here is Z. Let's make this correction. So this distance in nautical miles, and again we can subtend to the center here. This one is a little bit dull. Let's use a different color. Remember, this one is exactly the same like what we had here, because they are lying on the same latitudes, both from the north and the south. So the angle here are the same, and that is 110, as we have just gotten them here. So for us to get this distance, we also need to know the radius, and we're given the radius here to be 3,437 nautical miles. And that is the reason why we have to calculate in nautical miles. So for that case, let's go ahead and work out part B of the question, Roman number 1. So for us to get that, we can say it is an arc X and Z, and this arc will have a difference here, that is theta over 180 degrees. Since it is a great circle, then we use this radius r for our calculation. Now let's make substitution where our theta is equivalent to 110 degrees over 180 degrees times the value of pi as 3.142 times the radius of the Earth in nautical miles is 3,437 nautical miles. So let's get our calculator, enter everything there, and we find the answer. So that distance x, z is equivalent to 6,000. So here, let us write this in to 3 significant figures, counting it from here, 1, 2, 3. So we round 1 to this 9, making it 0, adding 1 to this, making it 6. x, z is approximately to 6,600 nautical miles. If you also need to make in decimal places, like maybe 1 decimal place or 2 decimal places or whole number, it will be 6,599. Any works, but it's important to first write what you have gotten from your calculation before you do any rounding or considering significant figures. So that is the solution for part B, Roman number 1 of our question here. Let's take a look at Roman number 2. It also says calculate the distance in nautical miles between y and z. Y is here and z is here along the cycle at latitude 30 degrees south, and we use the same values for pi and r. Now, when we look at this setup here, we realize that this is not a great cycle because it started in the southern hemisphere, so we can derive a certain, maybe let me first remove out this radius, and if this is our center of the cycle, we can also join this line to the center. Maybe since we use here O, this time let's do something like different, maybe D as our center, then we join D to Z, and let's call this angle beta. So if this is angle beta, so we need to get this angle difference beta. And how do you get the angle difference beta? We have to look at this longitude and this longitude here. And this one is 15 degrees west, while this one is 105 degrees east. Since they're in different hemisphere, then we also have to add to get this beta here. So let's make it down here again and say our beta as the angle difference is given by 15 degrees from the western hemisphere plus 105 from the eastern hemisphere. So when we add this together, we get 120 degrees. Now after that, this should be a small radius r here. Now for us to get the distance here, we shall consider our small radius, but remember our small radius r is given by capital radius times cosine of the angle subtended by the latitude, and that is 30 degrees. So at the moment, we can call it as alpha. So given this in mind, we can now go ahead and quote our formula and substitute what is necessary to our formula. Now coming around here, we can say our distance y, z is given by our angle here at the center under this beta over, by the way, you can use also 360 degrees. And if you do like that, we have to make sure that we bring into here, and we have 2 pi capital R now, because I'm replacing this by that. So we have cosine of our angle alpha. Now here we can make substitution in order for us to get y and z, and then beta is 120 degrees over 360 degrees times 2 times the value of pi was 3.142, then times r was 3,437, and we multiply this by a cosine of the angle 30 degrees. So we can go ahead and also enter this into a calculator. But before even entering, you can reduce some of these things down. This one down, maybe by 2, then by 2, that is 18. Now let's enter this in the calculator. Otherwise, you can continue reducing it down to have something smaller. But you don't need to stress yourself out. You just enter into the calculator and you get our answer right away. Yeah, so our y and z is equivalent to 6,234.83 6734. Now we can also round this up to maybe whole number, and we have this as YZ 235, because we just pick 1 from here and we add into this 4, making 5, and this is also in nautical miles, and this is how we calculate these questions during examination. But remember, during exams, you have to just use sort of formulas, like instead of using this 360, somebody can use just like what we have given here as 180, and you just eliminate the 2 automatically here, because we know if you divide 360 by 2, we get 180. So it's quite good to use this. I've just brought them all for this comparison. Otherwise, it's much more easier to use it in this format. But remember, all of them are the same. Thank you for watching up to this time. If you have gotten some value from this video, why don't you go ahead and subscribe to the channel, like this video, and share with your friends. And this small act you do really motivate us a lot in making this kind of videos. In our next video, we're supposed to look at another examination question. So please keep tuned so that you don't miss out. See you in that video. Peace out.